So, welcome back to Not Data Center News Asia. We are launching a full, long-form podcast, which Jonathan Atkin has kindly taken time out of his busy week in Singapore to join us on one of our pilot episodes. I'm Rhys Morgan.
James Murphy.
Thanks for having me, John Atkin, RBC.
Yeah, Jonathan, you were one of our early supporters on the weekly news show. It was great to have you come and lend some credibility to our earlier episodes, and we appreciate you having you back since. Now we're going to talk at nauseam until people realize that we actually have much less idea than we try and get across on the short episodes.
We'll see how it goes.
Jonathan, you've been in the industry far longer than James or I, and I think when you started out with RBC, it probably wasn't even called digital infrastructure. There was another fashionable term for it at the time. How did you get into the space?
So back when internet service providers and web hosting companies and fiber operators were kind of their own separate industries in the wake of deregulation, they all started to kind of converge. And so there were companies that were doing web hosting that needed to have internet connectivity to them. There were fiber operators that bought data center companies. So there was a little bit of a convergence going on. Companies like MFN, AboveNet, Level 3, Exodus Communications. So that's kind of when I got my start. I think I entered my first data center perhaps in 1998. So there was a convergence going on between ISPs, CLECs, and hosting companies essentially, and then a couple of pure plays like Exodus that emerged at that time.
How many of those are still around today?
So the buildings are very much still around, and they live as part of Digital Realty's portfolio and Equinix's portfolio and others. The companies themselves, there was a lot of disruption where they had balance sheet issues in some cases, or they had business model issues in others, and tried to do too much rather than sticking with just infrastructure. So there was a restructuring that went on in the early part of this century. And a bit of oversupply as well. But I kind of date the recovery to iTunes. So when the iPhone came out and you had all this content that needed a place to live.
2007-ish, is that right?
Exactly. Yeah, June of 2007. So in preparation for that, on both the East Coast and the West Coast, there was a recovery in some of these data center values. It wasn't just iTunes, but that's kind of what I was focused on. And there's other things that kind of led to a recovery. Internet businesses became healthier, and they all needed a place to live.
The part that's scaring me there is comparing the time lapse between what we think of as the .com bubble burst and iTunes. It's quite a long window of inactivity or sort of dark ages for the industry.
Yeah, I mean, there's a couple of missing years that I have, maybe between 04 and 07, and I was on a panel with Tesh Jervasula recently in New York, and he's been doing this a long time as well, and I think he dates it to 2004. It wasn't part of my lived experience at the time. I was focused on other sectors, but everyone's going to have a slightly different view, whether it's AOL, which was a big company at the time, so I think 04 might be a more accurate, depending on who you talk to, is when you might want to date the kind of the trough of valuation.
And what was your job title back then?
I'm kind of in a career rut. I've been doing the same thing for 26 years at RBC. So senior analyst.
Senior analyst, but like sector coverage, TMT, or what was the name at the time?
Yeah, well, telecom services.
Okay.
Telecom. Yeah, and then that's morphed into digital infrastructure because of the connectivity piece, and then obviously data centers and cloud infrastructure.
So now you're just very senior analyst.
Yeah.
Nice. It's hard to not read about that time in the history of the industry, and we would be about the 400th podcast to draw parallels with some of the growth that's happening today. But I was just thinking that when you were talking about that gap in between, I mean, do you see a lot of parallels? I mean, you don't seem hugely negative. You seem pretty bullish, like a lot of people.
Yeah, I think so there was a data center overbuild. And then there was a fiber overbuild as well, too much capacity. And people like Craig Scroggie have kind of made the point that back then the fiber was laid, but there was no traffic going down it. Now of course, broadband has played a hugely influential role in fostering innovation. But the early builders of fiber weren't necessarily the ones that were seeing the returns. It was sometimes companies that bought fiber out of bankruptcy that were making the money. Companies like Zayo over the years. But fast forward now to the year 2025. every data center that's getting built is being filled pretty much immediately with servers. And anybody that's embarking on a data center build project, at least if they have credibility, already has kind of pre-let the space or has clear line of sight towards getting a customer. So we're not at the point where there's speculative building, people hoping that it will come. The demand is absolutely there, and the pace at which you're able to build data centers is not enough to keep up with that demand.
Would the worry then be that the risk is further down the chain? So the building itself will still be used, but then the bigger part of the capex is now it's sort of inverted, right? So the really expensive part comes after you've added the building.
Absolutely. So this makes it different than cloud going back 10, 15 years where, a $100 million data center fully fit out with mechanical electrical plant. The servers inside are going to cost 400 or 500 million because the GPUs are just so much more expensive than CPUs were in the cloud era. And so one thing that kind of strikes me is that in the AI era, we haven't seen a hardware replenishment cycle. So let's just take companies like Microsoft, which has something like an $85 billion run rate capex, and Amazon, Google, Meta, they're all kind of in that same zip code. And that's all for growth for the most part. But at some point, all these H100s that companies of the ones that I mentioned, which were purchased a couple of years ago and then are only maybe in year 2 of operation, these things have limited useful lives, and it's up for debate as to how long GPUs last, but it might be anywhere from 4 to 7 years. And when they have to replace them, either because they physically wear out or they become technically obsolete, that's going to require a lot of capex on top of this $80-90 billion run rate that we're seeing. So we're a couple of years away from that, and so I think hyperscale capex is going to continue to grow at a pretty healthy clip for another 2 years, and then after that, these companies are going to have to ask themselves the question: do we see adequate return on all this AI infrastructure investment that we made? And if the answer is yes, then the capex is going to go up even further. And many of these companies that I mentioned are free cash flow positive and can absorb that, but not all of them are.
Let's rewind a little bit because I kind of got you on to do a bit of a primer for audience members who may not be as up on current trend cycles. We've dived straight into current trend cycles. So let's start from a position of AI. Why is this demand so big right now? So as a layperson, I do a good impression of one because I am a layperson. I'm looking at saying, well, ChatGPT came out in 2022. At that point, there was a small cluster of GPUs in Virginia that they trained it on. And there was and there still isn't really any large GPU clusters run by Microsoft and OpenAI in Southeast Asia. But in Singapore, I can still open ChatGPT right now, ask it questions, get photos generated, that sort of stuff. And I don't need trillions of dollars worth of infrastructure built to do that. So this building is in anticipation of something. What's driving this huge boom if it's not an immediately monetizable product right now?
Consumer adoption, demand, wanting to not lose out on the next wave of innovation, which could take decades or could take years. So no one knows where this journey is going to lead. I'll draw the analogy with fiber. It played an incredibly useful role in society and getting broadband connectivity, but it wasn't necessarily a money-making business, at least in the early years. Same with AI. It's not clear what the monetization and return on investment is. And so there's hints that one hears from all these hyperscalers, these big internet and software companies on their quarterly investor calls are talking about increased engagement levels or better recommendation engines, and so they can charge more for some of their ad-based businesses. Or if you're running more of an enterprise AI model where you're charging for access for other businesses to access your tokens. So there's lots of ways in which these companies are getting paid, and there are companies that do talk about the revenue that they're generating, and it could be 40-50 billion for some of the large foundation models, or it could be single-digit billions for companies that are operating AI alongside cloud. So it differs by company, but there's no kind of holistic view yet that we are definitively recovering our cost based on the revenues that we're seeing early in AI. But we're in the very early innings here.
Yeah, because I would sort of say to justify capex on new development, you want to be saying, well, if we don't spend this capex, we won't be able to sell a certain thing, which is either worth more than our current product, or it's a newer product that will generate new customers. And although there is an argument that reducing latency in Nano Banana might make more people use enterprise photo generation, that doesn't seem to fill the gap in capex that's being used to implement it locally. The one exception possibly is it seems that a lot of TikTok's business model is around channeling towards this, as you say, recommender and the ability to have their control over what adverts you see when you see them. And I read that they are predicting that almost 99% of advertising content will be either AI curated or AI generated in a quite short period of time. So they seem to have quite a clear business case on it.
Yeah, and Meta might be doing kind of similar. So that's more of a B2C or with the consumer in mind. That's kind of driving some of that attempt to monetize. And then there's more kind of pure enterprise. You can access my model to run your AI startup or whatnot. So a lot of things are being tried, but I think the jury is still out, and we're still in the very early innings to figure out what that return on investment is. Mm-hmm. But I think the attitude of these big companies is most of them have sufficient balance sheet capacity to continue to spend, and they don't want to miss out because we really are in a new era in terms of how you can use these things for your daily life and to run your businesses. And if you're not providing those tools, then you clearly are missing out versus your peers.
Yeah, Rhys has furiously been typing prompts into the various AI tools to come up with a name for this podcast, which we don't yet have, and it hasn't been successful yet. So that's an example of future value creation, maybe, versus what we've seen.
It had a few good suggestions. I won't say them now in case one of them is the name of the podcast, and then it becomes awkward when people make fun of it later. But yeah, it's had some good suggestions. I made a good picture of a data center value chain with only one spelling mistake, which was pretty impressive.
There we go.
We are meant to be talking about data centers, though, and this is probably a time for James to chime in. So when you've got these use cases that we're talking about, and as I say, at the moment, from my understanding, whether it's in China or in America, but the vast majority of your training and the use for these GPUs is happening in the United States still. And then if we're using these tools in Asia, at the moment, the inference is still, so there's a POP maybe somewhere in Singapore, but the inferencing is still being done probably on American GPU. What does the architecture for data centers look like? Why is it different? And maybe you can talk a bit about how that's changing site selection as well, because we're just having panels today at ITW, and yeah, they're talking about completely different data center plans, locations between inferencing and between training, and compare that to cloud as well.
So so pre-cloud, you would have what Bill Barney kind of coined the term storage operating centers, and that can be pretty much in the middle of nowhere. It's not latency sensitive. You want to go where the resources like land and power are cheap, and so you have examples of that in every region. It could be the Nordics, it can be Pacific Northwest in the U.S., or it can be in parts of Asia that are remote, like Inner Mongolia, would be an example, and that's where the content might reside, where you're basically just operating storage arrays. So that's been part of the architecture for a long time.
What sort of years? Like, this is pre-cloud, so this is early 2000s.
So prior to 2012, let's say.
And this is just companies storing reposits of photos or documents.
Emails and photos and things of that nature.
And what was the term?
Storage operating centers
I've never even heard the term.
Yeah. I mean, I don't know that it's a very prevalent term, but people might think of those as remote locations for data centers. But think of that as storage, right? Because it's infrequently accessed content. But if you have a database that needs to be pinged because you're running an e-commerce or financial trading engine off of it, then it has to be close to a major city. And if it's a consumer model, maybe like Netflix, where you need to serve content, then you need to kind of put some of this cache content at cable head ends or in telco central offices. So there's content that's going to be frequently accessed where latency matters, and that'll be closer to the CBD or closer to some of these suburban locations. And then the infrequently accessed content where you maybe need to update it once, at 2 a.m. or whatnot, will be in remote locations.
So at this time in history, then you've got your, call it an Equinix IBX or some sort of downtown carrier hotel.
Carrier hotel, exactly.
And then you've got the storage operations center out in the burbs. And then I presume we're moving towards the cloud era next with what you've described to me before, the availability zone architecture for each city. So how does that work?
Yeah, so cloud, Amazon was the pioneer, and then Microsoft followed, and then Oracle and Google as well, and then there's Asian versions of that as well. But the architecture is that a lot of businesses are running software that might have been written, in the 70s or earlier, and enterprise applications, whether it's new software or old software, it doesn't behave well if you have too much latency. If you're running like multiple branch offices of your corporation, and so cloud kind of needs to have a defined architecture, and every hyperscaler has their own sort of parameters as to how close the zones need to be, and how close each region has to be to a certain city. So 40 milliseconds or less. I think at one point IBM, that was kind of their parameter when they were running their cloud platform, and so you need to have AZs in essentially every time zone or close to each city, and so that's kind of this the intermediate between it. So that's not going to be a carrier hotel, because for cloud you need large contiguous blocks of land and power. So you're typically going to be in a suburban location.
So the reason then for the 3 buildings of rough size, what's the
so data centers that were architected at the beginning of this era were there was a premium on redundancy and having backup to your backup, and having gen sets that are generators that turn on and operate the site if the grid goes down. And a big part of the cost of a data center is the mechanical electrical plant to provide that uptime on those rare cases when the grid is not reliable. So the batteries and the generators are actually quite significant, even though they're almost never used. What the cloud companies sort of discovered is that we don't need to build or be in the most expensive data center. We can go to something that's a little bit lower quality, and then we'll make up for it with geographic redundancy. So if we go all in on a 100% uptime cluster, you never know when there might be some sort of a natural disaster or incident that would bring that site down. So they're going to put 3 of these things in kind of a triangle around each city. Amazon kind of pioneered that, and then other companies that developed that might have been using exactly those same employees that were doing it for Amazon. So you see these sort of teams
does look very similar, yes.
yeah. So journeymen that might have pioneered Amazon's AZ architecture might have then moved to another company, and so there's been a lot of knowledge transfer ever since the cloud era.
And this is where you have the birth of the likes of Digital Realty, sort of boxes of cheap power that are relatively downtown, but not in the center of town.
Yeah, suburban. And so data center build costs have actually gone down since, say, 2012 to 2020, partly because you just don't need as much backup, because the customers, namely Amazon and Microsoft and Oracle and others, would rather have geographic diversity, and then they don't mind if there's an outage, because then they've got these 2 others as backup.
Yeah, Microsoft claimed that if we were to be using the same workloads that we're using not on the cloud and they were all still on-prem, we'd be using, so it's 86% saving in terms of power and cost. So we'd be, what's that, 5-6 times more power cost usage to do it all on. Now, obviously, that's the cloud company saying that, so there's probably a vested interest in those calculations. But the costs do seem to have gone down with scale.
Well, yeah, I mean, cloud data centers are operating at 80% or higher utilization, and enterprise data centers, those that are like owned by banks, might be like 40%. So you definitely do get a benefit from having a pooled set of resources with higher utilization.
And this is kind of when I got into the industry. James is a little bit more experienced than I am. I came in as it was becoming the sort of the race to the west, the gold rush in Asia of AZ deployment. So it seemed like every week a hyperscaler was announcing a new AZ in a different Southeast Asian or North Asian country. There's 3 now in different parts of Japan, China, etc. And I guess the business case then sounds like, so if you've got 3 20 megawatt data centers to make your AZ, which is going to cost you, say, $600 million of capex, $200 million a pop, then you need to be making you need to be looking at that as your return on investment case for your cloud sales in that country to justify bringing Azure or AWS or Google Cloud to that particular country. Okay, so that was the market at the time. how do we now get on to AI, where the numbers have shot through the roof and the site selection process is evolving again?
So first of all, cloud is still a very profitable business. You saw revenue growth just this past quarter for most companies well north of 20%. And Amazon is the largest cloud company, and I think they may have only grown 17%.
They were devastated. Only 17% growth.
$100
billion business.
But off of a huge base. So it clearly is a proven product, and there's still amazing amounts of IT that happen in the corporate environment that have yet to go to the cloud. So there's still a lot of growth left in that category. With AI, you can't, we might be many years away from being able to kind of declare victory that AI saw a massive return on investment. As I mentioned earlier, the jury is still out. But with AI architecture, you've got these massive foundation models where you can get more efficiency by having massive scale. And where do you find massive scale? It's really away from these cities where there's pockets of power available, land is cheaper, and you can build massive campuses, whether it's West Texas or Wisconsin or parts of Malaysia, or whatnot. So.
Okay, so this is the training models. So now we're at the point where people are seeing these photos online and these news articles where you've got voluminous buildings in parts of Texas. You've got tens of thousands of GPUs lined up, and they're all cross-connected. And it's basically just trying to compute the next frontier model. Yeah. Which presumably, if it wins, will be better than all the other models and therefore generate the money.
And the models have to be retrained, and so there's still I wouldn't say there's exponential growth in foundation model size and intensity, but it's linear growth, and the slope of that line is still pretty steep. And then inference, which is where you so if training is a cost center, inference is essentially running a model and trying to make money off of it, or at least applying it, and then hopefully you get paid for it. So inference is widely believed to be much more latency sensitive, and I think it depends on what type of inference. If you are in a Waymo vehicle, in San Francisco,
I'd like that to be not latent when the car comes out in front of me.
Yeah. I mean, so all the command and control is on the vehicle, right? So that's instantaneous. But if it's ChatGPT or something text based, you can still do that from middle of nowhere. Or if it's image generation, you want to wait another half second to get something that's 5 times better. So I think one thing I've kind of come to realize, and I have dialogue with some of the folks that are these big model companies like OpenAI and Anthropic and Gemini and others, is that a surprising amount of inference actually takes place where training takes place. So this argument that all inference has to be latency sensitive, not true. It's a continuum. Some inference is highly latency sensitive, and some of it is highly latency tolerant. So inference will live in a lot of different topologies, whether it's 20 megawatt data centers or 200 megawatt data centers or 2 gigawatt data centers.
And you used the phrase retraining. So is that running the model again with different inputs, or what's retraining? Because I've heard it before, and I think I've heard it used in slightly different contexts. So retraining, tell us.
Yeah, I think it's just refining the model based on current information and making it better.
But that all has to be done at a training. So you mentioned then that you can sometimes do inferencing where the training. Is that just a product of that's where the GPUs are right now? So because please correct me on the site selection here in Asia, but we haven't seen yet the deployment of inferencing zones in this region. Like there are GPUs being deployed in countries, but those are predominantly going to be used to train things that are, whether it's a Chinese hyperscaler wanting to be able to train stuff outside of China, whether it's Google's announcement in India, which presumably is because India's got its own sovereign data laws and they see a big enough market there that they want to be able to train data for the Indian market in India. A lot of the Thai stuff is supposedly so they'll be able to train things in different languages in Southeast Asia rather than in the States. But there's not inferencing deployment yet. Is that just a product of we don't know what it looks like, or we don't have the GPUs, or?
I think innovation in GPUs, it's definitely happening, but it's not happening fast enough to kind of serve the demand for it. But I think it's just people are still discovering, what inference is actually needed, but in the meantime, it's easier to find capacity in a remote area just because of geography than it is in a CBD carrier hotel or in a suburban cloud site. So vacancy rates, in this sector in places like Northern Virginia are pretty much at record lows. So even if you wanted to run a lot of inference in, say, Northern Virginia, you wouldn't be able to. So you have to go further afield. And what I think a lot of the tech community has discovered is that it works okay, even if it is 2 hours further, out in the countryside compared to where you thought you needed to have inference.
Yeah, because the latency differences are quite small. I was kind of racking my brains trying to think of many use cases beyond something like a self-driving car or, I don't know, like guiding a missile or something that really has to be on point. But most things that you ask, it's kind of a question answer format, or I understand that there's something to do with real-time conversation that they think would be a big driver.
Yeah, so if it's real-time audio and then especially video, these things start to become noticeable. So when inference when AI usage becomes more than just a text interface for the vast majority of people, then I think there'll be a premium on inference coming out closer towards the edge and closer to the end user. And the mobile infrastructure industry, which is another area that I focus on, which is towers. Towers are not seeing, they're seeing demand because of new spectrum being deployed or because of 5G build-outs. But the traffic growth on mobile networks is not being affected by AI. It just isn't. It's not. And so until we start using our mobile phones to upload perhaps AI-generated content because the inference chips are on the Samsung or the Apple devices, or we start using our phones as a video AI interface. And I think this will happen. But so far, the mobile phone industry and the mobile infrastructure industry has not seen any impact at all from AI.
And is that because the products don't exist, or is that because
the applications haven't yet been developed?
Okay, so it's okay.
Well, I suppose if you're asking your chosen bot to generate a picture or generate a video, the compute is being done somewhere in West Virginia apparently, and what your mobile sends or receives is just a picture or a video. So nothing's changed from the mobile and the mobile operator's perspective compared to just once we moved to sort of 4 and 5G and we could send videos. There's not been a step change for them yet, I guess.
But there could be AI generated content. So there actually are inference chips on these. I mean, so if you put your phone in flight mode and take a picture of a flower, it'll tell you what you're looking at. So that's a very primitive example of inference that exists today on 2-year-old iPhones. But there'll be more elaborate inference that can take place. Whether it's a mobile device or something that you have in your home, and then how are you going to get that to the rest of the internet? That will require probably upload traffic for mobile networks that we haven't seen.
So in the meantime, for training, then what we're looking at in the shifts of data center architecture and therefore demand is places where you can put a lot of chips and a lot of power at a competitive cost. But then I assume when this is coming outside of, what is the build cost difference? So if we're building in a cheap place in the US, let's say these mega camps coming up in Texas, where they've got a lot of, power, resources, people who've done this sort of thing versus somewhere like Asia or Europe, what's the difference?
Vertical, right? So in Asia, you have a lot of 8-story data centers that are probably 20-30% more expensive than a horizontal design that might be ground level plus 2. So it's all about how many stories high the data center is. I think that's probably the biggest determinant. And then seismic. So New Zealand and Japan, here in this region, and then California where I live, you're going to add another 5 or 10% on top of the build cost just because of earthquakes. But it's not so much. And then land cost, even though it has quadrupled in certain U.S. jurisdictions, it's just not that significant compared to the the core and shell and the mechanical electrical plant. So everything's gone higher in terms of just the piece parts, but you do get scale advantages to building a 2 gigawatt site versus a 200 megawatt site, and so that's been kind of an equalizing factor.
And in terms of the numbers, so I think most people around the world will use the old $10 million a megawatt number when talking about a facility generally for a cloud or even a wholesale style facility. the numbers that we're seeing for AI, I think specifically for training, they seem to be significantly lower, or is that myself and Rhys misreading press releases?
So let's just say here in Asia, you got bookends like India. India might be mid single digit million per megawatt, and then Japan might be 18 million, and then in between would be kind of that 10 to 12 million US per megawatt, maybe in the States now, if you're just putting together a business plan from scratch, the number might be 12 million.
Even for AI.
So for AI, if it's going to be liquid cooled and you're going to use direct to chip liquid cooling, you might add another million per megawatt, or maybe another kind of roughly 10% on top of it. So the direct to chip liquid cooling, which is sort of an add-on. So a cloud data center that has a chilled water loop, not to get too technical, you could quote unquote AIify it and do direct to chip even after the fact by adding CDUs and kind of that secondary loop, and that it's been done, and it adds maybe a million on top of that.
But I suppose this is where we see a number of neoclouds whose background is in crypto mining, because the facility requirements weren't that different. It was large amounts of cooling at scale, probably somewhere remote and shady. And that's for different reasons in this case. But it seems to be that's so there's that transition. But then, and in those cases, the cost, when we budget it, we're talking core and shell plus operations is our sort of CapEx. But now the number is shifted up to the chips. So that is a bit cheaper, but it's still, you're spending a lot per.
Yeah, I mean, $100 million data center fully fit out, the kit inside might be 400, 500 million, because that's just how expensive the GPUs are. Whereas in a cloud data center, you didn't have that kind of mismatch between the equipment inside the racks versus the base building. They were more equal. Now there's like a massive disadvantage. Or a massive mismatch. But the pivot from crypto data centers into AI data centers, I think part of that is just around value creation. So crypto companies might be valued by the market at 4 or 5 times EBITDA, whereas data center operators get valued at, say, 20 times EBITDA. Or higher. So it's prudent, if you have access to power, which both crypto needs as well as AI, the highest and best use of that, at least as valued by the market, is to create more of an AI data center business than purely a crypto business. So I think that kind of explains the pivot that we've seen. Plus, there's just so much demand for data center capacity, and these companies that have been doing Bitcoin mining for a while, that certainly is a comparative advantage that they have, because they've been in these remote areas for quite some time. Now they're still learning how to build a different type of data center that might be more expensive, but the energy piece, which is kind of one of the major pinch points towards creating AI capacity, that's something that they have. It's less of a constraint for them.
Yeah, I suppose if you see some of the pitch decks floating around the Middle East of sites, if you look at the same site over the last 5-10 years, it might have been pitched as a potential refinery of some sorts, then moving into being a crypto mining site, then being into AI. But the core and shell is still, we've got lots of power generation coming into a building. We're just trying to find as you say, maximal value use case for for that block. Where does that leave the risk then? So, if you've got your core and shell, you've got your operations, then you've got your chips, and whether or not that's directly owned by the end user, the chips are the most expensive part in an AI data center as it stands. And they also have the fastest refresh rate. So is that also the most profitable part to be involved in? Or, because we often view things through the lens of the data center part, which is the building and the operations.
If you're getting monthly recurring rent by renting capacity, measured usually in megawatts to an off-taker, like a hyperscaler or a neocloud, and as long as the customer pays their rent, you're going to get a certain return over multiple years, and investors value that at roughly 20 times. Profitability on the equipment side is very, very different, and it's kind of beyond my area of expertise to focus on the semiconductor value chain. But clearly, you've seen, just based on the stock prices of some of these semiconductor companies, that there's massive value attached to being able to have access to the components that make GPUs.
I wasn't even thinking from the semiconductor, more from the neocloud layer of the business. So I don't know how, because they're not charging rent. I guess they're selling tokens. a lot of cases.
So the NeoCloud model is basically, some of them do build their own data centers, but a lot of them are renting space from third-party operators. So they're more of a capital light model, at least when it comes to the data center infrastructure. But then they have to finance the GPUs, and maybe they're getting companies like NVIDIA to literally invest in them to help them do so, or there's GPU financing options out there. And then their challenge is that if these GPUs last, let's say, 5 or 6 years, they want to make sure that they're charging high enough for GPU rental to recover their cost within the lifespan of a chip.
And the lifespan of a chip, like I think you touched on it in the first 10 or so minutes, but does it just wear out? Technology obsolescence? Like, what does the end of a chip life actually look like?
So it could be both, but physically it is finite. I mean, we've seen this with cloud with CPUs, is that they do wear out. Depends on the environment in which they operate, the temperature, how many read-write cycles, depending on what the CPU is being used for. But and so it's not. There's no expiry date that applies to every chip. It's kind of statistical. So there'll be a mean time to failure. Let's call it 5 years. Some will last 8 years. Some will last 3. So it's all kind of statistical. And since cloud is kind of a shared resource, the customer never really notices it. It's incumbent on the cloud provider just to make sure they've got that capacity, because you're not literally renting each chip. You're just renting this collective pool of assets. It's the same with AI tokens as well. So I forgot my train of thought here.
But the tokens well, not the tokens themselves don't get less valuable, but as you said, the infrastructure that gets less valuable. If the chips are now 3 years old, if you think 3-year-old chips now, that would be pre-H100s.
So if you want to, so physically they may wear out, in which case when they do, and if enough of them wear out, if you're going to be operating, a cloud platform or an AI model, you need to replenish them. But then the technical obsolescence kind of piece is that if you want to be on the cutting edge for your foundation model, you really will need to have the latest and greatest. So what happens to a chip that becomes technically obsolete before it becomes physically obsolete? Well, that can be used for inference. So AI inference is probably less dependent on having cutting edge GPUs. So they can experience kind of so if they become technically obsolete after 2 or 3 years, they can have a rebirth as an inference chip, maybe even in the same data center, and still be highly useful.
This is interesting, because I was going to ask you next about the next wave of potential boom we could see in Asia, which would presumably be the deployment of inferencing across it. So we've got our cloud regions coming across various cities. Most hyperscalers now have presence in most of the Asian countries they want to or will do soon. But then what does inferencing look like? But a couple of things you mentioned. So potential for reusing the chips anyway, and possibly doesn't need to be as close to the use cases. So is there going to be a continued boom of inferencing, or is that going to just take up the old training centers back in the US and China?
So you pointed out, I think correctly, that the vast majority of training, to date has taken place in the US, and a lot of people think that will continue to be the case. But Australia, it's quite clear, just given the size of deals that we're seeing there around capacity commitments, is that the workloads in Australia are not just serving a domestic use case; they're serving a regional use case elsewhere. Perhaps U.S., but since the U.S. is not yet really short on constraints, it's probably serving Asia, and I think that's going to be happening more and more, because certain. If you look at the map of APAC, most hyperscalers, when they think about their AI investments, they look at Japan, they look at Australia, they look at Malaysia, they look at India. Some look only at India and Australia, actually, and then some look at all four. It depends on the company. But Australia is clearly playing a clear role, because you've got rule of law, you've got rules of the road that people kind of abide by. You've got more certainty around just doing business, and the latency, while significant, maybe that becomes less significant if Perth or Western Australia becomes the next AI hub, which possibly could happen by the time I visit you next time, maybe in a year or so. So,
yeah, because the latency from Sydney, where there's the biggest data center cluster, still in Australia.
So Melbourne might surpass Sydney in the next 18 months, but Sydney for the time being is still the bigger market.
They're both on the south. So the latency from there to a user in Tokyo is going to be not far off the latency from San Francisco to Tokyo.
Mm-hmm.
So
so North Asia kind of has its own ecosystem. So I think you need to kind of segregate Korea and Japan. They're going to be served domestically from local resources, but India, Thailand, Vietnam, Malaysia, Indonesia, et cetera. So that it's a little bit like Thailand is emerging as a hub that might serve neighboring countries. Here in Singapore, you've got Facebook, which built a massive data center, now Meta. And I think for the longest time, Facebook users in India were probably served out of Singapore and possibly still are.
Yeah, they seem to have sprung back onto the scene as a buyer recently. I thought they were taken up by their Singapore data center for the longest time in Southeast Asia. Are you allowed to comment on customers on this?
There's actually very little workload being run out of that Singapore facility still. Like a small fraction of the announcement a couple of years ago. But in terms of moving back onto the chips, and we might be getting hypothetical here, but maybe our audience will like hypothetical. Someone used the analogy of iPhone with me previously. So when the first iPhone came out, it was a significant jump forward. And probably as they've progressed up to, what are we on now, 17, 16?
Yeah, 17 Pro Plus Max Giga, I think, or something.
Yeah, the increments or like the performance differences have probably been smaller than with each of the earlier models. Is that likely what we're going to see with the chips? Because there's nothing stopping me from using a 15 and probably having more or less the same experience as someone with a 19 plus giga extra large double screen 3-camera edition.
I think there's a race, where NVIDIA has a clear leadership position in terms of capability and scale, and they're continuing to innovate and create new generations so they can outdo themselves. But then you got AMD and Huawei, trying to close the gap. So I don't know, it's not my area of expertise, but I think the capabilities are still growing at a very, very steep rate. I don't think you're seeing minute improvements from generation to generation. I think they're still quite significant in terms of the amount of compute that you can get on that next generation of GPU.
I suppose this might be different if we were looking at an inferencing race, because if we're still looking at frontier models being the driver for the spend and people wanting to stay ahead, then they are paying for the latest. Because if, according to AMD, they're probably only 6 to 12 months behind, but that 6 to 12 months is still deal breaker for a frontier model. But for if you were doing inferencing workload, I guess you could buy AMD or Huawei or whatever else might be more available.
Could it potentially kind of almost commoditize and then the difference in a 6-month-old chip be next to nothing, whereas now it's pretty significant?
You'd have to sell your NVIDIA stock if that was the case.
But at the right time.
Awesome. So if we're looking then at the, what we were talking about predictions in Asia landscape here, so we've not seen vast amounts of training deployment, although we are seeing, as you say, India, Australia, and then Southeast Asia. For the inferencing that comes here, is this likely to be just an expansion on the existing zones, or are we going to see a whole new shift? I mean, I don't know if you've seen any in the States where there are specific inferencing sites, and does it look different in that local market, or is it just a blur at the moment?
It's hard to piece together a lot of. So we can talk about Japan separately, but I think in most of the world, if you look at where the GPUs are being deployed, they're being deployed by companies that we would associate with as being cloud providers, and so it lives within Amazon, within Microsoft, within Oracle, and within Google. There's a lot of AI investment going on in Japan, but to my understanding, the companies that I just mentioned, at least until recently, a lot of what they were doing was plenty of spend in Japan, but for cloud. I think that's starting to change, and you probably are seeing GPUs within some of these Western clouds, but a lot of domestic investment going on by Japanese enterprises. So you got SoftBank has kind of talked about making their own investments. I think at one point Hokkaido was what they were looking at. So there's activity there, and then just local industries, manufacturing intensive, where they're deploying enterprise AI. The Japanese government has subsidized domestic enterprise purchases of GPUs. So there's a lot of subtle, not consumer-facing GPU compute going on in Japan, and so that's what makes the AI topology there perhaps a little bit different than almost everywhere else.
But some of these companies that would call themselves a sovereign cloud or a local neo cloud ultimately are, before they can even develop their own, they're leasing the space to an American hyperscaler anyway to do things on their data centers. Or a Chinese hyperscaler.
So you'll have localized, sovereign AI that might often be within the auspices of a multinational company. Sometimes you'll see it, within a domestic operator. It depends on the country.
Okay, so we are possibly going to see locally produced LLMs and bots, or we're too far behind now. It would be too late for Korea or Japan or Singapore to produce their own equivalent of.
I wouldn't say there'd be massive foundation models. I'm not creative enough to think of a world where the ones that exist today. I think Grok. Grok GROK, not G. So there's Grok GROQ, which is inference as a service, and there's GROK. I don't know that there's going to be one that's created after Grok. So Gemini and Llama and Claude and OpenAI, obviously has talked about national initiatives in the Nordics and the UK and elsewhere, and I think that you'll see local tweaks to the base model. So you can basically take the weights of a model that might have been trained in the U.S. and then localize it domestically. So it's a little bit of a hybrid where a lot of the foundational training may have taken place in the U.S., but then it gets localized and suited to national preferences with sensitive data and whatnot, within the jurisdiction.
Going slightly off script here, and just kind of on the back of what you said there around the kind of the foundation work being done in the US and then localized, are people starting to talk about fears around some of this localization? Will some of the outputs that you get from the same foundation model in different countries potentially vary massively based on political systems and things like that? Is that something which ever gets discussed with you?
These are legitimate questions. It doesn't really cross my radar at this point.
So I was in a discussion at W Media's Bangkok event, and I had the odd privilege of moderating a panel on automation. And one of the panelists was a doctor, and he was talking about the use of it in medical fields. And he did say that one of the challenges that they had was the Thai government had wanted them to have their own healthcare automation, it's a bot that basically looks at scans of tumors over time and then forecasts the growth of a tumor. And this is one of the first, I think, in Houston, they did one of the first pioneers of this, and one of the best uses of AI to start with was it can normally, if you've got cancer, you get a scan every sort of 6-12 months. The AI was able to go take one scan and then forecast the growth of the tumor with incredible accuracy over a period of time. But when they were trying to do this in Thailand, they didn't have enough quality data. So this is where it comes back to the old thing that IT nerds are always arguing about on LinkedIn is all the compute and everything is great, but what's the quality of the data you're training it on, and where are you storing that data? And I presume that's somewhere that American companies have a significant edge of years of just tabulated data.
Yes, and then if it's a uniquely sovereign type of requirement, traffic and I'm just trying to think of something where there's data that's not public. Healthcare data is probably a great example where you really, if you want to run a better national healthcare system, you can't train that in the U.S. So that's where you would take the model architecture, more or less that exists, and then tweak it to suit the needs of the National Health Service or whatever local health authority.
Yeah, training your healthcare data in America would be a risky start, I think. Right. So I don't know whether we're meant to do like a sort of social wrap up at the end of these things, or whether we carry on with AI chat the whole way through.
Well, we could steal Stephen Bartlett's Diary of a CEO and leave a question for John to ask our next guest. That could be anything.
Who is that next guest?
We don't know. So that's part of the fun. So it could be.
Look, we haven't got a name of the podcast. So Varun has said yes, but he's traveling. There's some Summit. So we got a couple of people lined up, but we haven't booked them in yet. So thank you very much for tuning in. Hopefully this was even more informative than our usual bite-sized 10-minute episodes. Thank you very much to Jonathan for coming on and letting us deep dive into some of your wisdom of the years.
Thank you.
Yeah, and Jonathan, thank you very much for being one of our pilot guests. Much appreciated. And thanks everyone for watching or listening wherever you digest your podcasts.
Yeah, if we didn't say anything wrong, we'll be back probably the same time next week as you're getting these released.
Great. Thanks, everyone.